Hello, everyone. This is Kene once again. Today, I'm here with another problem that we will be solving together, right? And it has to do with Roman numerals. This time, we'll be converting Roman figures to their Arabic numeral equivalent. Okay? So I'm going to share my screen, guys, and we'll look at the questions together. All right. So write a Python program that accepts a Roman numeral, converts it to its Arabic numeral value, and displays the result. So three things. We get the Roman numeral from the user, then we compute to get the Arabic numeral for it, and we should display the result. That is, our program should display the result. Okay, guys. So let's see. I'm going to start with just an example so that we understand the thinking, behind the solution. Say a user gives C, XL, all right. This should be CXLIV, okay? Now, guys, if you recall, let me use this as well, CLXVI. So I'm going to use CLXVI. You know, we know, and I suppose we know that C is 100, and then L is 50, X is 10, V is 5, and I is 1. So that gives us 100 and 60, 65, 66. So that's 166, right? So all we need to do is to add up the numbers, right, represented by the letters. So C or L. So C is 100 and L is 50, and so on and so forth. That gives us 166. Well, guys, let's look at something. Let's look at the pattern here. The number that goes before a particular number is greater than the number. So the first is not going to be used. So we're not going to check because the first number cannot have anything in front of it. So we take the second one. We see that, fine, 100 goes before this 50 and 100 is greater than 50. Then I can add. So I can say 100 plus 50. Then I come to 10 and I inspect what is in front of it. That's 50. So again, 50 is greater than 10. Then I'm going to add. Then I come to 5. What's in front of it? 10. 10 is greater than 5. I'll do the addition. Then come to 1. 5 is greater than 1. I will do the addition. So provided that a number at any point, right, is less than the number to its left, the number in front of it, provided that it is less than that. So 50 is less than 100, I will do addition. But let's look at this other one, right? CXLIV. Now, I can't do the same thing, right? I can't say 100 plus 50 because L is not 50. So I'm going to try to, work things out here. 100 plus, now what's X? X is 10, L is 50, I is 1, and V is 5. Now, guys, let's look at it. I'm going to take 100, fine, nothing in front of 100. Then I come to 10. 10, guys, is less than 100, right? So I'm going to add. Remember what we did here, 50 is less than 100. So again, here, 10 is less than 100. So I'm going to have 110, right? But then, just before I do that, before I actually do this 100 plus 10, that's adding these two, I will come to 50. And then I realize that 50 is greater than 10, than this 10. So I'm not going to do addition there. It shouldn't be, right? I should do addition only where, a particular number is less than what is in front of it, the number in front of it. So 50 is not less than 10. Therefore, I can't do 50 plus 10. So there's a problem now. I need to do something differently. I need to do subtraction. Now, I already got 110 by doing 100 plus 10. Only for me to realize, checking 50 now, I realize that it is greater than 10. So that addition of 10 shouldn't have taken place. That's what we are going to understand. Provided that this 50 is greater than 10, then I shouldn't have added this 10 to this 100 because this 10 shouldn't exist. This 10 here shouldn't exist, provided that this 50 is greater than 10. So I'm going to take off that 10. I shouldn't have done that addition. But of course, as a dumb computer, I did it anyway, right? So I need to take it off again. That brings me back to 100, right? Then we know that XL, is 40. Once 50 is greater than 10, then I'm going to do subtraction so that I can arrive at 40. I already know that XL is 40. So how do I get 40 when I have 10 and 50? That is 50 minus 10. So what I'm to add to the 100 is 50 minus 10. That now is going to give me 140. Are you guys with me? So please don't just say, oh, since XL is 40, so that's, and L is 50, X is 10, so I'm just going to do 50 minus 10. Remember that once the computer encountered this X, it added it. It added it. So let me even put it there so that we'll see. It added it immediately. That's 100 here. It added it to the 100 once it encountered the 10. Then it got to this L, which is 50, and then realized that, oh, this 50 is greater than 10. Then it shouldn't have added this 10. It shouldn't have added. So what it needs to do first, what the system needs to do first, is to remove the 10 that it had, should I say, erroneously added. So it takes it off so that we are back to 100. Then we can now proceed to doing yet another subtraction to get my XL, which is 40. So 50 minus 10 is 40. It is that 40 now that I will add to this 100 to get the true value of CXL, which is 140. So now I have 140, right? Great. So starting off with 140 now, up to this point now, CXL. Then the computer sees I, and I is 1, right? Then it comes to the next letter there, V. And then it realizes again that V is greater than I. V is 5 and I is 1. And anytime you have a number that is greater than that which is in front of it, then there will be subtraction there. IV is 4, so it ought to be 5 minus 1, right? But the computer, before I come to 5 minus 1, we need to understand something. Once the computer encountered this, from going from L to I, once the computer encountered this I, it gave the digit for it, 1, and added it to what we had before then. That's 140. All right, so I'm going to do 140 plus 1. But then, guys, seeing that 5 is greater than 1, the computer will kind of, yeah, should I say, blame itself. Oh, it shouldn't have added this one to 140. It should have somehow waited to see what is after the one. But of course, it does things, procedurally. That's why it gave us this addition of one. It did the addition of one. So I need to remove it. I need to take it off. It shouldn't have happened. So when I take it off, I am back to 140. Then I'm going to add to 140. I'm going to add to get IV. I need to get the value of V, which is 5, and the value of I, which is 1. And because 5 is greater than 1, 5 after it at the back is greater than 1 in front, then I'm going to do subtraction. So that will be 5 minus 1, right? Okay, so 5 minus 1 is 4. 140 plus 4, that's 144. So CXLIV is 144. You understand why for CXLIV we had some subtractions, right? But for CLXVI, there were no subtractions, just additions all the way to get 166. That's because successive numbers are less than the ones before for them. So 50 is less than 100, 10 is less than 50, 5 is less than 10, 1 is less than 5, addition all the way. But in this case here, you see that 10 is less than 100, addition, no problem. But 50 is not less than 10, so there ought to be some subtraction there. Then I continue, and I add and continue. 1 is less than 50, there will be some subtraction. Oh, sorry, there won't be any subtraction here. He puts the 1. But you see now that 5 is greater than 1. That again will require some subtraction. So guys, you can play this video. You can replay this segment of the video to get a decent understanding of what is taking place here. Right. So I hope we understand it. I could let me quickly, very quickly convert another Roman numeral to its Arabic equivalent. So say I have D or MCD XXIX. So M is 1000, right? Then it takes C afterwards. C is 100. Then it takes D. Now, guys, D is 500. And remember that once you have a number that is greater than what is before it, what is in front of it, there's going to be subtraction. So remember, guys, again, that the computer ought not to have what? Done this addition with 100, using this 100 here, that is the C. Because 500 here is greater than 100. But because it encountered, immediately after M, it encountered this C, that was why it actually did the addition. But realizing that 500 now, which is after the C, is greater than C, it has to remove this 100. So it ought not to have done this addition. It was done in error, right? So the system has to remove it. So Python will take this off. Take it off. That's 100 that it added. Then now consider CD. You understand? So how do I get 400? Since I already know that CD is 400, that's by saying 500 minus 100, which is C. So D is 500, C is 100. 500 minus 100, I get 400. It is the 400 that I'm going to add now. So once I do this, I get my 1000 back. Then I can add it to 500 minus 100. So that gives me 1000 plus 400. That's 500 minus 100, 400. 1000 plus 400, 1400. Then I'll take the 1400. Then it continues. The next after D is X, which is what? 10. Now, guys, 10 is less than D, which is 500. So I'm just going to do an addition. So that will be 10. Then again, I'll take the other one. The other number is, the other letter there is X, and X is another 10. And this X is not greater than X. They're actually equal. So this will be another 10. So I think, again, let's know what we have at this point. That's 1420, right? Okay, so I'll get 1400, use 1420. Then I come to I. Immediately, once it encounters the I, it would give us 1. Then it comes to X. And then the computer realizes that, oh, hey, wait a minute. This X is 10, and it is greater than I in front of it. I is 1. And you know, guys, we said that any number after another, and which is greater than that number, what I'm saying is, this X comes after I, and the X is greater than I, then I need to do subtraction. But before I do the subtraction, we have to make the computer realize its error. It shouldn't have what added this I the first time it encountered it. So it needs to give it up. We need to remove the 1 from this value that we had initially, because this X is greater than I. So I'm going to, the system rather, not me this time. System takes this and removes that 1 that it added when it ought not to. Then I get back my figure, 1420. Then using 1420, I will now, of course, again, guys, we know that Ix is 9. So how do I get that 9? Using X, which is 10, using X, which is 10, and I, which is 1. That will be 10 minus 1. I get 9. So I'm going to add that 9 to the previously held value. So 10 minus 1, I get the final result, which is 1420. 10 minus 1 is 9. So 1429. Just something like that. So that's the way, you know, the answer is computed. Now let's use code here to try to replicate this process. Okay, now guys, to do that, I'm going to get the input from the user, right? So I'm just going to say it's my string. The string there is a number because it's coming from the input method, it's a string. So I'm going to say input enter Roman numeral. Enter Roman numeral. Then I'll take it. And before I continue, I'm going to create a bucket. In this case now, because it's Python, it will be a dictionary. That is collection of key value pairs. Collection of key value pairs. So I'm able to link a letter, that is the Roman figure, to its Arabic numeral equivalent. So guys, let me just create my dictionary. So I'm going to call my dict. Key value pairs, I'm going to say this is I, and the value of I will be 1, comma. Next will be V, which is 5, the value is 5. The next, X, and the value is 10. Then L, and value is 50. Next will be 100. So I should say C, and the value is 100. And the next is D, the value of 500. And finally, I have M, the value of 1000. 1, 2, 3, 4, 5, 6, 7. Right. Now, guys, remember the thing about the dictionary. If you want to get access to one, then you need to use the name of the dictionary, my dict. And in square brackets, you have the key, and the key for this one is I. So to get my dict, let me just print this out. To get my dict, to get one, I'm simply going to use my dict. In square brackets, I will get the key, and that will give us the value, right? So let me quickly run this. Just anything is not used yet. So guys, what I wanted to show us is how to grab a value in a dictionary. So the name of the dictionary and the key for the value, you get the value. I hope you understand. All right. So now I'm going to use a for loop. For I in range 0 to length of my string. So this is how many characters, how many letters, constitute that input. Then I'm going to go through each of those characters. Okay. Then I'm going to do some checks, right? I am going to make sure that the first character does not involve any subtractions. Like I'm going to make sure of that the first character comes with no subtractions. After all, there's nothing in front of it, so we can't be checking whether that character is greater than what is in front of it. So I'm going to do this if the first character, which stands for I, is greater than 0. And another check, guys, I'm going to also ask myself, right, is I, which is the character at that point, greater than what we had in front of it? What was in front of, or what is in front of that character? So if I have character, if I'm at the position for character B, I need to check what is in front of the B, which is A. Then I'm going to do subtraction. If, guys, let's get it. If the B is what? Greater than A in front of it, I will do subtraction. And if the computer had erroneously done any addition before realizing that I is greater than what is in front of it, it will remove that number that it added, and then it will now do the Roman numeral operation, which is, say, for example, IX, it will now be 10 minus 1. So before it does the 10 minus 1, it has to remove the 1 that it added before doing 10 minus 1 again. So that's what we need to check now. Check if B is greater than A. And how do I do it? I'm simply going to use my, I want to get these values. So I'm going to use the key. My dict, watch, guys. my dict, right? And how do I get I? Since I cannot, I is not numerical, V is not numerical. So how do I use numbers to get this I, to get the key? Guys, this is it. Just understand that this I points to the position, right? So what is this I that is at this position right here? Okay, but I need to understand that it is going to come with my string. So again, I will take my string, just like this. So this here internally, this inner expression here, I mean this inner value here, so to say, my string at position I, that is, say I have MC blah 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 XX ID. So this will be my string at position 0, my string at position 1. So that's how I am grabbing the letters. Okay. Then since I know, for example, that this is the first letter, right? Now that first letter, for example, I now, what is it in my string? So the letter of my string becomes the key to get the value in my dictionary. So if this is I, for example, my string at position I is, say, M. Okay, let's say M. This is M now, right? In my string at position I is, for example, M. Then that M will be the key to grab a value in my dictionary. So if this is M and I give it as, so something like this, guys, it would give me 1000. But I need a way of grabbing that, of getting the M, which is the key for 1000. So that is simply going to be that input at this particular position. That will give me the key. And with the key in the dictionary, I will get the value. All right. So if my dict gives, let's say my string at this position is M. M is the key to grab the value within my dictionary. So that will give me something like, for example, 100. So I'm now going to check, is that number greater than what is in front of it? So I'm still going to take this whole thing, and do a -1. That will give me what is in front of it, what is in front of the letter at this position, right? So -1. If it is so, remember, guys, how since V is greater than I am going to remove the I that was erroneously added and then still do a 5 minus 1. So I'm actually removing 1 2 times. So that's just like saying 2 times 1. So just multiply this I and remove it from the number that you have. Because first I will remove it the first time because the computer ought not to have added it. Then in getting the value of IV, I will still remove 1 from the 5. So I'm removing 1 twice. That will be 2 times 1. Then when I get the 2, I will remove it from the number that I already have. So let's see how we are going to do that now. I know it can be quite technical, but I hope that we get it eventually. So if this is the case, if all this is the case, then I'm going to do what next now? I will, okay, fine, guys. I'm going to create an answer variable to hold my answer, and I'll set it to 0, right? Set it to 0. Then I am simply going to do ans will be equal to ans plus that number, the ans plus the number, you know, the value of ans will keep changing. It will keep being updated. So when I grab the new value of ans, I will set it to the same ans variable. So I will grab the value, and then provided that that value is greater than what is in front of it, I will remove the number 2 times. I mean, I will remove the number in front of it 2 times. So I'm going to do minus 2 multiplied by this particular one here. Right? I hope we understand. So with that, I will now store the new value in this same variable ans. So the value of ans is updated. But if it is not, if it is the first number, then I'm not going to do anything. I'm just going to put the number. Or if this I is actually less than what is in front of it. So it's either that we have the first number or that number is greater than what is in front of it. Then just put, I mean, that number is less than, the number is less than what is in front of it. Then just add the number. We're not doing any subtraction. So that's what I'm going to put in this else. Just make ans plus my dict at that position. Right, guys, we are done with this. Then at the end of it, I'm going to print my answer. And that answer is ans. Okay, so let's see. MCXLIV. Oh, I ought to have removed this, please. This is causing an error. So I'll run again. MCXLIV. That's 1144. Then let me try all additions. So that will be MLX. So you see that fifth, there is progressive reduction. So no addition is going to take place. MLXIX. So this is M, 1000 plus L, 50, 1050. X is 10, 1000, that's 1050 plus 10, 1060. Then, oh, I shouldn't have, I wanted all, progressive addition. That is a number following the other must be less than it, the number in front of it. So let me just give this MCLXVI 1150, 10, 5, and 1. So that's it. There's progressive reduction. So that means all addition, no subtraction. Let's get it, guys. So we see 1000, M is 1000, C is 100, 1100, L is 50, 1150, X is 10. So 1,150 plus 10, 1,160. V is 5. So add it to 1,160. I get 1,165. Then plus 1, 1,166. All additions. All right. So I hope we get it, guys. Yeah, please, you can watch the video again, and I'll leave the source code on my website, and that is www.thetutoraid.com.ng. Right? Thank you guys for listening. I'll see you in my next video. Bye.